Hey, what's up you guys, my name is Harrison and welcome to School of Swipe. So now I'm going to be talking about graphing and calculus on your TI-84. This is part of a video series on how to use your calculator and do some math. Yeah. Okay, so I'm just going to be talking about some graphing and how to do it. It should be quite easy. So okay, so in general, you need to know this. So this key right here is your X key or T key. What comes out of it depends on what mode that you're on. So don't sweat too much about it. So okay. So let's say even if I want to type sine theta, don't sweat it. Just type sine x unless you really need to switch to theta for some reason. But right now I can't think of any reason that you might need. So then you can just press graph or something. So okay, it might be kind of hard to see, so there's a few things I need you to know. So there's this thing called zoom 0, which is zoom fit. So if you don't know what is the best zoom to see the entire thing, I suggest you just use zoom fit. So something like that, then you should be able to see the whole of the sine graph that I just calculated. It's obviously not very smooth, so so that's the not so cool thing about zoom fit. So what we could do is go to maybe window, and x minimum I can just make like maybe -5, and maybe make this 5, and okay, let's try that again. So see, it looks a lot smoother now. So so yeah, if you have no clue at all, maybe just zoom 0, zoom fit. That's pretty cool. So what I can also do is, let's say I want to find at what angles does sine x equals to half, right? So I can do this, and see, so it does that. Okay, so what I can do is I can find the intersect, so I can second calculus. Okay, so there's like a bunch of these, so I'll just explain it. So let's say value means like any value of x. So if you want x to be like 0, and it'll plot for you and find the actual value for you. Of course, 0 means the x-intercept, so we're looking for something where it crosses the x-axis. So when you put it in, you have to see that one side of it is lower than the x-axis. When they're asking for left bounds and right bounds, one of them must be above the x-axis and the other one has to be below it. So and guess just means anything. So yeah. Okay, I need to make I need to put in a side note, which is sometimes you may get a very strange error, which is like you may see like a bunch of numbers, gibberish, and something to the power of e minus 99 or e big numbers. So usually if you see e and negative numbers, it actually means 0. It's just their way of calculating, and or like 0.9999, it could be just 1. So it's something that happens with the TI-84. You just need to be able to recognize it when you see it. So sometimes that might happen. Okay, so I'm just gonna switch the mode to parametric equations. So just to give you an idea, so if you switch to parametric equations, all of a sudden it looks very different. So your x and y will both be defined in terms of t. So let's say I have t and I don't know, t square minus 1. I have no idea what this is gonna look like. Okay, so it looks like that. Yeah, so what you can do is go to calculate, and you can calculate the value. You insert a value of t, and you can calculate the value of y and of x. It's not, they can't calculate the x or y intercept. You probably have to do that manually. But what's great about this is that you can calculate your dy dx, dy dt, dx dt. I think that's pretty fantastic, and I think that if you need to do some parametric equation where you need to find dy dx and at specific values of t, I think that's helpful. If you want to find the equation in general without subbing in a value, you probably have to do that by yourself, but this is a good way to check it. Okay, so let's see. So yeah, we talked about differentiation, parametric. You can also do differentiation for Cartesian, so I'm just going to go and change it back right now to your regular old functions. It should go back to what we saw just now. Okay, so I'm just going to change this to maybe x2 plus 2x plus 3. I don't know. So yeah, note that how like when I switched the mode from parametric back to like your regular functions, this thing just updates itself, which I think is pretty cool. So I'm just gonna go and delete this and go back to graphing it. Alright. And we don't see anything. Okay. Alright. So zoom 0 to the rescue again. Okay, so I'm just going to go and calculate some stuff. Minimum, maximum, we'll talk about that later, but let's try dy dx first. So let's say I want to calculate dy dx at x equals to 1. Let's try x equals to 1. Go. And there you have it, your dy dx equals to 4. So yeah, so another thing it can do is it can calculate your maximum and your minimum. Yep. Okay, so yeah, it's the same thing with the intercept. You need to see the left bound and the right bound, and now what they're looking for is again a change in sign, but not a change in sign of the function itself. The y coordinate, they're looking for a change in sign of like the slope of the graph. So for this curve, we're obviously gonna look for a minimum, not a maximum. So let's just go ahead and yeah. So left bound, it has to be to the left of the minima, and right bound, it has to be on the right. I can't really see. I think it's not going to work, but because I didn't press it properly. But let's just try this again. Okay. Next time I should just change the zoom so that I can see it properly. Alright. Yeah, so the error that I was talking about just now, it just came up again. So when you see minus 99999.77, it's probably minus 1. So yeah, it's just some estimating kind of the way it calculates stuff, but you should be able to see it and say, yeah, it's probably minus 1. So the last one that I want to talk about is obviously integration. So we've already seen that it can do differentiation. I don't think it can do it, yeah, without actually subbing it in directly for you. So anyway, right now I'm going to change the window, and instead I'll leave the x-axis alone, but my y minimum, I'm going to switch it down to maybe -1 so we can get a better look at what's going on. So you can see this. So we should be able to do some integration here. So we're gonna integrate it from, okay, sure, 0 to 3, 0 to, I don't know, 3. So it's great. They even shade it for you. They put the whole thing there. Fx dx is the integral of fx dx is 27. So so what I noticed is that you can go to math, and then you can go down to finite integral, and what? I think in the later version, when you do this, they will actually have like the thing, and then you should be able to type in everything. The software doesn't have it, I think. Yeah, it's a little bit annoying. Okay, we're gonna try it anyway. Okay, so I'm gonna go x, comma 1, comma 0, comma 1. So it should be able to do that. I have no idea. I think something like that. Yeah. Okay, so in this form, I think it is the first thing is the function that you want to integrate. The second thing is just what you want to integrate with respect to, and then after that, lower bounds, upper bounds. In the later version of this calculator, you should be able to see like the integral sign, and then you should be able to type in lower bound, upper bound, and everything is very clearly spelled out for you. But yeah, it should be pretty self-explanatory. So yeah, I think that's all for graphing and calculus. If there's anything else you want me to like just try to demo or figure out for you, just let me know in the comments. And you know, that's all for now. I'll see you in the next video. Okay, bye.